discuss the de Broglie hypothesis, the de Broglie equation in a bit detail, and after understanding the concepts, we will try to solve a problem from IE Irodov's collection of problems. So we have the expression that for the wavelength lambda as h by p, the momentum. This is nothing but equal to h by mass into velocity. I can also equate this to 2 pi h bar divided by root of 2me, where E is the kinetic energy. We know the expression for kinetic energy, E is equal to half mv square. Now, multiplying both sides of this equation by m, I can rewrite this expression as 2me is equal to m squared v squared, nothing but p squared. Or I can write p as root of 2me, which is what I have shown in this expression. Now, we have h bar, which can be approximated to the uncertainties delta x multiplied by delta p. The wave equation, the de Broglie's equation that clearly incorporates the Heisenberg's uncertainty principle, which says that it's not possible to predict or measure accurately the position and the momentum of an electron at a particular instant. So delta x is the uncertainty in position, delta p is the uncertainty in momentum. Now this delta x and delta p, which is nothing but h bar, I can write as h by 2 pi. Now, it is clearly evident from the left part of the equation, the de Broglie's hypothesis, that lambda is an attribute of a wave, whereas p, the momentum, is an attribute of a particle. If you observe this equation, it is evident that as the mass of the particle increases, precisely for macroscopic particles, the wavelength will be so small, or even in the case of particles that are with more energy, or particles that are energized, the wavelength will be so small that it cannot be measured. At the same time, for particles in the subatomic domain, as the mass of the particle becomes very less, the wavelength can be measured. Now, looking at this problem, we are expected to calculate the amount of energy that is supplied for an electron, so that its de Broglie wavelength decreases from 100 picometer to 50 picometer. So, bringing in the substitution, we'll try to put this expression, we'll try to put this part of the expression into our substitution. We have lambda 1 is equal to, I'll write it as h by root of 2me1, and similarly lambda 2 as h by root of 2me2, because as per this expression, h bar is nothing but h by 2 pi. Planck's constant is always a constant, so I can, in order to find out the energy difference, the energy that is to be supplied for its decreasing from lambda 1 to lambda 2, I can find out E2 minus E1. So I'll rewrite this expression as E1 is equal to h squared, because transposing it I can write h squared divided by 2m into lambda 1 squared, and at the same time I can write E2 also equal to h squared divided by 2m into lambda 2 squared. This after transposing and simplifying the expression, I get these two expressions, from which E2 minus E1 can be calculated as h squared divided by 2m into 1 by lambda 2 squared minus 1 by lambda 1 squared. Okay. Now, proceeding further, I have E2 minus E1 is equal to h squared, nothing but 6.626 into 10 power minus 34, this whole square, because we have h squared, divided by 2 into mass of electron is 9.1 into 10 power minus 31. Let me erase this part. Minus 31. Into 1 by lambda 2 squared is nothing but 50 into 10 power minus 12 the whole squared minus 1 by 100 into 10 power minus 12 the whole square, as I bring in the picometer substitutions. So simplifying this, I get E2 minus E1 as 7.23 into 10 power minus 17 joules. The reason why I bring in joules is that in the substitution, Planck's constant has got the unit joule second, and the mass is in kilograms, whereas lambda 2 and lambda 1 from picometers we are converted to meters by incorporating this 10 power minus 12. So on simplifying, we get 7.23 into 10 power minus 17 joules. We also know that 1 electron volt is nothing but equal to 1.602 into 10 power minus 19 joules. This is available from our tables, from our Clark's tables. Okay, then now proportionally simplifying, what will be the equivalent for 7.23 into 10 power minus 17 joules? To find out, is equal to 451.74 electron volts, or I can write it as 0.451 kilo electron volts, and thereby